Hi, my name is Isaac Brodsky. I'm a co-founder of Fused, and in this video I'm going to demonstrate how I built the Overture Maps Example UDF. This is a UDF that queries Overture Maps data out of Source Cooperative. This data has been geo-partitioned by Fused ahead of time, and includes building data, transportation data like connectors and segments, administrative boundaries, and a few other themes in the dataset. In this video, I'm going to focus on the process that I went through. So the UDF that I make at the end isn't going to exactly match this UDF, but you can always see this in the public UDF's GitHub repository if you want to take a look at what I ultimately came up with. I'm going to start with another UDF as the basis for this. I'm going to start with the Microsoft Buildings US UDF. So this is a pretty simple UDF, which is loading in some data from this table, this Microsoft Buildings US data, and showing it on the map. And I'm looking here at New York City, and I can see that there are indeed buildings. And if I zoom out, instead of seeing all the buildings in the US, it's showing me partition information. So I can see that there are areas where there's more partitions or fewer partitions, and this indicates kind of roughly the density of buildings in those areas. So more partitions, more buildings, fewer partitions, fewer buildings. And I can see that, for example, New York City shows more partitions than somewhere in upstate New York. And if I zoom out enough, I can see that this is indeed a US-only data set. So I'm not seeing data in Canada, I'm not seeing data in Mexico. And if I go somewhere else in the world, I'm of course not seeing data there. So I'm going to focus again on New York City. And I'm going to zoom in here. And I'm going to start modifying this UDF to instead refer to the Overture Maps data. So I need a few different pieces of modification in order to do this. One is that the path for this data is a little bit more complicated. So I'm going to move this from being a parameter to being something in the UDF itself. I need the release here, and the release I'm going to get from the documentation is this string. I also need the theme, and the theme is going to be buildings, and the type is also going to be building. Now, this data set is a little bit more complicated in that the buildings are actually split into 5 parts for partitioning reasons. So I'm going to need to do a little bit of additional work here. So let's say num parts is going to be 5, which I got from the documentation. And I'm going to handle my simple case here. And if I have more parts, then I'm going to need to do something a little bit more complicated, which is I need to append the part number. And I believe I also need to update this common UDF that I'm using. So I'm going to switch that to main, the latest version. So I have some unupdated code here. And if I look at what I have loaded, I can see that I have a bunch of data frames in this array. So in order to bring these together, I need to import pandas and concatenate this. And this might still have some issues, and that's going to be because of serialization problems with this this data set. So there's some columns in this which are a little wacky, and I'm going to do some kind of serialization hacks here in order to make this a little bit easier to work with. So now I have my buildings in New York, and I also have all the properties of those buildings that I can see in the tooltip, and I can also select some building and then see what are those properties here. So now that I've updated this to look at Overture, I don't want to just look at New York. I had that with the Microsoft data. I want to start checking the Overture data and kind of what's interesting, what's different about Overture. So I'm going to zoom out here. I'm going to go into full screen, and I'm going to start looking in different parts of the world. And one of the first things that I'm curious about when somebody tells me that, for example, there's a global data set is it in fact global? So I want to look in different parts of the world. And I'm not seeing any countries that are like left out. I can see that there are some areas like Siberia or the middle of Australia where there's not a lot of buildings. That makes a lot of sense. And I can see that, most of the rest of the world has buildings. One thing that stands out, though, is I know that China has a very large population, but I'm seeing comparatively much fewer buildings here. There are some buildings, there are partitions that are covering this area, but it seems like there's maybe too few partitions. So I'm going to zoom in on this and see if we can find out a little bit about what's going on. So as I load here part of Beijing, I can see that there are buildings. It's going to take a few seconds to load in. The way I wrote this UDF is not quite as efficient as the version that's in the GitHub repo. But I can see that there's some sparsity to it. So if I zoom in here, I can see that there's these blocks and there's buildings in them. There's also more roads, but there's no other buildings. And this could be the case, but it seems kind of suspicious to me. So I'm going to switch to the satellite view. Excuse me. And I can see that there are indeed more buildings here that are not being represented in the data set. So it seems like the fill rate for this part of the world is maybe a little bit low. So one area that I have been looking at for testing this data set has been London. So I'm going to switch to that now. And looking here, I can see a lot of buildings coming in. I can see that there are a few areas here where there are no buildings or very few buildings, but looking at the labels, it looks like these are mostly parks. And if I switch to satellite view, you can see that indeed these are parks. Obviously, there's not that many buildings in the river, although there are some things that are being marked as buildings. And actually, one thing that caught my eye that seemed a little suspicious is that there's, looks like a bridge or something here, which is being marked as a building. These other bridges are not buildings. So this one being a building, it seems maybe a little bit suspicious. I can look at satellite view, and I can see it looks like there's some kind of train infrastructure here. There's rails, and so maybe this is a rail bridge or something. And I can see this is London Blackfriars, and I do have to admit that I've kind of cheated. I looked this up ahead of time, and I looked it up on Wikipedia, and what Wikipedia told me is that this is a railway station, and it does indeed span the river, and it's a little bit unusual in doing that. So this building makes sense in the context. So now that I have updated this UDF to show buildings, I want to go back and modify it a little bit more because there are all these other themes and data types in the Overture data on Source Cooperative. So I'm going to make a few more modifications here. Right now I just have the theme and the type set as buildings and building respectively, and they're just hard-coded into this UDF. But I want to make these customizable in the parameters of the UDF so that when I call the UDF through the API using REST or Python or one of the integrations, I'm able to customize that when I get these buildings back. So I'm going to start by just moving these parts into the parameters of the UDF. Just modify this a little bit, and of course this still works. But having to change a bunch of different parameters each time in order to get this to update to a different type, I'm going to change this to the segment data. And segment, I need transportation as the theme, segment as the type, and numparts be 1. And it should come in and show me the road network here. So I can do it that way, But having to change 3 different parameters each time, it seems kind of inefficient. So I'm going to copy paste some code in here, which will allow me to auto detect these either if they're not set, or I could just always do the auto detection, because a lot of these things can be determined from what the type is. So here I've added something that'll help me determine what the theme is and what the num parts should be depending on what the type is. So now if I change type to building, I don't need to change anything else. And I could also say place for the POI data in Overture. And that'll load right in. So now I have this as a parameter, but I don't necessarily want to be messing around with the code every time I want to change that, or every time I want to look at something different in this map. So what I'm going to do is I'm going to go to settings, and I'm going to add a parameter here, call that type. I'm going to add some suggested values for it. So building, place, segment, connector. And now that I've done that, in my UDF list, when I expand this, I have a form element for this. So I can just change it here to segment. And now my UDF is called with segment as the type instead of building. Or I can change that to place. And it makes it a lot easier to explore this data set, which I'm going to pan around a little bit here to show you. And I'll change that back to segment. So this was a quick overview of how I built the Overture Map UDF in Fused. You can see the final UDF that I wound up with on the fused.io/UDF's GitHub repo. And I'm looking forward to seeing what you build with Fused. See you next time.